Developing AGI using generative AI, a comprehensive roadmap. Developing artificial general intelligence, AGI, with generative AI, Gen AI, requires a well-structured roadmap, covering core components, milestones, technologies, and development phases. Today, we're diving deep into one of the most exciting frontiers of technology, how generative AI is shaping the path toward AGI. If you're an AI enthusiast, tech professional, or looking to future-proof your career, this video is for you. We'll explore the roadmap to AGI, the role of Gen AI, also how you can position yourself for success in this rapidly evolving field. Stay tuned, because the future is closer than you think. Roadmap strategy for AGI using Gen AI. Phase 1, Foundation, Understanding Intelligence and Learning Frameworks. Objective, establish a strong theoretical and architectural foundation for AGI. Study and analyze current AI architectures. Deep learning, transformers, GANs, RNNs, diffusion models. Neuroscience insights, how the brain works, cognition, memory, reasoning. Limitations of current AI, lack of generalization, common sense, reasoning. Define AGI learning paradigms. Self-supervised learning, SSL. AI should learn from vast unstructured data. Neurosymbolic AI. Combining deep learning with symbolic reasoning. Causal AI. Understanding cause-effect relationships for reasoning. Multimodal AI. Integrate text, vision, audio and real-world interaction. Select a baseline Gen AI model for enhancement. GPT-4, Gemini, Claude, Llama, or develop a new architecture. Incorporate memory augmentation and self-reflection capabilities. Phase 2, Core AI Model Development, Enhancing Generative AI for AGI. Objective, develop a scalable, adaptable, and self-learning AI model. Architect a scalable and modular AI core. Cognitive foundation models, self-learning models with reasoning. Transformers 2.0 and next-gen AI architectures. Sparse attention mechanisms. Mixture of experts, MO, for efficient learning. Self-improving architectures, like AutoGPT, Baby AGI. Enhance generalization and reasoning. Implement meta-learning. AI should learn how to learn. Create semantic memory modules. AI should retain and recall knowledge dynamically. Enable context awareness. Understanding past interactions and applying logic. Develop continuous learning and self-evolution mechanisms. Implement active learning loops. AI selects what data to learn. Automated fine-tuning and adaptation. Adjusts learning based on performance. Self-debugging models. AI corrects its own mistakes and optimizes learning. Phase 3, Embedding human-like cognitive abilities. Objective, introduce common sense, abstract thinking, and problem-solving abilities. Memory and knowledge storage systems. Episodic memory, AI remembers past interactions and learns from them. Long-term memory, LTM, and short-term memory, STM. Neural knowledge graphs for structured information storage. Developing abstract and causal reasoning. Causal inference, AI should understand why things happen, not just correlations. Symbolic AI integration, logical reasoning combined with deep learning. Multi-objective decision-making, AI should handle ambiguous and conflicting goals. Multimodal understanding and interaction. AI should process text, images, videos, 3D environments, robotics. Train AI in simulated environments before real-world testing. Phase 4, AI Autonomy, AGI Self-Governance and Self-Optimization. Objective, make AI self-improving, autonomous and adaptable in real-world scenarios. Self-evolving neural architectures. Neuroevolutionary algorithms, AI adjusts its architecture dynamically. Self-supervised multi-agent systems, AI trains AI without human intervention. Enhanced decision-making and ethics implementation. Implement AI ethics modules, safety, fairness, bias control. Alignment with human values and morality frameworks. Robotic embodiment, optional but critical for AGI. Test AGI in humanoid robots or simulated robotics environments. Enable real-world interaction and adaptability. Phase 5, Real-world deployment and continuous improvement. Objective, deploy AGI in controlled environments and refine iteratively. Controlled testing. Implement AGI in sandboxed environments before real-world usage. Monitor behavior, safety and decision-making processes. Human-AI collaboration and alignment testing. AI should explain its reasoning in an understandable way. Ensure alignment with societal and ethical norms. Iterative refinement and open-source collaboration. Keep improving AGI through collaborative development. Implement self-governance AI networks to prevent rogue AGI behavior. Technologies and tools for AGI using GenAI. Final vision. AGI powered by GenAI. The future of AGI using generative AI will lead to self-learning AI, understanding and evolving without explicit programming. Multimodal and adaptive AI, learning from diverse sources, text, images, speech, robotics. AI-human collaboration, enhancing productivity and problem-solving, safe and ethical AI governance, ensuring AI aligns with human goals. Artificial general intelligence, AGI, is no longer just science fiction, it's an evolving reality powered by generative AI. As we move closer to achieving true intelligence in machines, understanding the roadmap and key technologies behind AGI is crucial. Whether you're an AI researcher, developer, or someone passionate about the future of AI, now is the perfect time to get involved and upskill. What are your thoughts on AGI? Do you think we'll achieve it in the next decade? Thank you for listening. For more information related to career path, job role, or description, follow our channel Career Quest.